And also on Trump's agenda, Panama and the vital canal linking the Atlantic and Pacific Oceans. The new president has repeatedly said that the U.S. should take back control of the waterway. He spoke of it at his inauguration.
China is operating the Panama Canal, and we didn't give it to China. We gave it to Panama, and we're taking it back.
We're here today to examine a monument to American ingenuity, the Panama Canal.
Imagine if the world's most vital waterway concealed a secret powerful enough to disrupt global trade in an instant. The Panama Canal, a masterpiece of engineering that facilitates billions in cargo movement daily, now faces an unprecedented crisis. What started as faint tremors has escalated into a situation sending ripples through the global economy. But beneath these troubled waters lies an even greater revelation, one that challenges everything we believed about this iconic passage. This isn't just another maritime dilemma. It's a discovery that could rewrite history. The hidden truth beneath the Panama Canal, a crisis no one anticipated. Picture a typical morning at one of humanity's greatest engineering achievements, where massive vessels slice through pristine waters, carrying the lifeblood of global commerce. Now imagine that same morning transforming into something that would shake the foundations of international trade. What began as subtle disturbances in the Panama Canal's lock system would soon unravel into one of the most significant maritime crises of our time. Deep beneath the surface, something was stirring. The first warning signs manifested as unusual vibrations, subtle at first, easily dismissed as routine operational noise. Yet, these vibrations held a secret, one that would soon command the attention of engineering experts worldwide. As the vibrations persisted, growing more pronounced, the Panama Canal Authority realized they were facing something unprecedented. Underwater drones, armed with cutting-edge technology, were deployed to probe the murky depths. What they uncovered was alarming. Hairline fractures creeping through critical sections of the infrastructure, each one a ticking time bomb. But these weren't just ordinary structural flaws. They hinted at something far more sinister lurking beneath the waterway's surface. What makes this revelation even more unsettling is the canal's crucial role in global trade. Every day, vessels carrying billions in cargo navigate these waters, their movement forming the lifeblood of international commerce. The moment reports surfaced of possible structural failures, the repercussions were swift. Markets wavered, shipping companies braced for impact, and governments worldwide were on high alert. As engineering teams scrambled to assess the extent of the crisis, they were on the verge of uncovering something that would turn this technical emergency into a mystery stretching back centuries. The scale of what we're facing here extends far beyond routine maintenance concerns. Geological experts, armed with advanced monitoring equipment, have identified what appears to be a previously unknown tectonic fault line, a sleeping giant beneath one of the world's most crucial waterways. This discovery transforms our understanding of the region's geological stability and poses questions that keep engineers awake at night. Consider the sheer magnitude of what's at stake. A waterway that handles more than 5% of global maritime commerce, a crucial link between the Pacific and Atlantic Oceans, now potentially compromised by forces far beyond human control. The U.S. Army Corps of Engineers' rapid deployment speaks volumes about the severity of the situation. When the world's leading engineering minds drop everything to assess a canal, you know something unprecedented is unfolding. What's truly remarkable is the widespread impact on the global economy. Markets from Shanghai to Rotterdam are already adjusting in anticipation of significant disruptions. Shipping companies are discreetly mapping out contingency plans, considering longer and more expensive routes, reminiscent of a time before the canal even existed. This is the kind of crisis maritime experts have long speculated about but hoped to avoid. With mounting pressure on the Panama Canal Authority, they are racing against time to assess the full extent of these structural issues. Every ship passing through now carries more than just cargo. It bears the weight of uncertainty. The real question isn't just how to address the immediate concerns, but whether we're prepared to rethink one of the core assumptions of global trade. Yet beneath these turbulent waters, as engineers grappled with the mounting crisis, their high-tech equipment was about to reveal something that would make the structural concerns pale in comparison: ancient structures that had lain hidden for centuries, waiting to tell their story. The engineering nightmare beneath a technical deep dive. The true scale of the Panama Canal crisis emerged through a barrage of technical data that left even seasoned engineers struggling to comprehend its magnitude. Advanced structural analysis revealed a network of stress patterns unlike anything documented in modern maritime engineering. The damage wasn't just surface level. It represented a complex matrix of interconnected weaknesses that threatened the very foundation of this crucial waterway. Geological survey teams, equipped with state-of-the-art seismic monitoring equipment, mapped an intricate web of fault lines beneath the canal zone. Their findings painted a disturbing picture. The tectonic activity wasn't isolated. It formed part of a larger geological system that had somehow remained undetected during decades of operation. The data suggested potential movement patterns that could trigger catastrophic failures with minimal warning. The technical assessment revealed a worsening situation. Stress tests showed that key support structures were functioning perilously close to their maximum capacity. Every passing vessel was no longer just part of routine trade, but a measured gamble. Engineering teams faced a difficult challenge: sustaining operations while averting a potential disaster. Real-time monitoring systems started triggering warnings with unsettling regularity. The structural crisis at the core of global trade had moved beyond mere speculation. It was happening in real time, with repercussions capable of reshaping international commerce. Integrity issues weren't static. They were dynamic, evolving challenges that seemed to worsen with each passing day. As one section showed signs of stabilization, another would display concerning patterns. The canal's complex lock system, once a marvel of engineering precision, now exhibited signs of stress that defied conventional repair approaches. Meanwhile, shipping companies worldwide started receiving technical briefings that forced them to confront an uncomfortable reality. The canal's operational parameters were being revised downward, drastically affecting global maritime logistics. Vessels that once passed through routinely now faced stringent new restrictions backed by engineering data that couldn't be ignored. As the technical reality of the crisis became clearer, the economic implications began to cascade through global markets, transforming an engineering challenge into a potential economic catastrophe. The economic shockwaves began rippling through global markets with devastating precision. Shipping giants began rerouting vessels around South America's Cape Horn, extending journey times by weeks and driving transportation costs higher. The ripple effect was a tangled web of disrupted supply chains, affecting everything from consumer electronics to critical medical supplies. Economists, monitoring the unfolding crisis, drew troubling comparisons to the Suez blockage. Only this time, the threat wasn't a single choke point, but the broader instability of a vital global trade route. Insurance firms swiftly revised their risk assessments, triggering premium hikes that sent shockwaves through maritime commerce. The economic fallout became evident in unexpected ways. Ports from Singapore to Rotterdam faced unprecedented congestion as shipping companies scrambled to adapt. The disruption reached far beyond the shipping industry, impacting automotive plants struggling with part shortages, retail giants warning of inventory delays, and energy markets bracing for fuel transport disruptions. Global trade analysts, piecing together the implications, began outlining increasingly dire scenarios. The potential for sustained disruption at the Panama Canal threatened to reshape global trade patterns that had been established for over a century. Markets that had long taken the canal's reliability for granted now faced a stark new reality, one where this crucial shortcut might no longer be dependable. In boardrooms across the globe, emergency meetings became the norm as companies grappled with a troubling question: How do you maintain business continuity when one of the world's most vital trade arteries shows signs of failure? As the economic implications continued to unfold like dominoes across the global stage, a new challenge emerged. The race to prevent this engineering crisis from evolving into a full-blown geopolitical standoff. When global trade holds its breath, the cascading crisis of the Panama Canal isn't just a local engineering challenge anymore. It's evolving into something that threatens to reshape global commerce as we know it. Picture this. Container ships, once flowing smoothly through this vital waterway, now forced to make decisions that ripple through every corner of the global economy. Supply chain managers worldwide are witnessing their carefully crafted logistics networks unravel in real time. Major retailers have already begun sounding alarm bells. The disruption isn't just about delayed shipments. It's about the fundamental restructuring of global supply chains built over decades. Manufacturing hubs in Asia, accustomed to reliable trans-Pacific routes, now face the prospect of significantly extended shipping times. The effects ripple through every stage of the supply chain, from sourcing raw materials to delivering finished products. Stock markets across the globe are experiencing extreme volatility, with shipping and logistics stocks fluctuating sharply from Wall Street to Tokyo as investors navigate uncertainty. This reaction isn't just about immediate disruptions. It reflects concerns over long-term shifts in global trade patterns that have sustained economic growth for decades. The timing is particularly troubling as global supply chains are still recovering from previous setbacks. This crisis risks sparking a new wave of shortages and price hikes, with industry analysts closely monitoring key indicators as inventory levels decline and transportation costs rise. The question isn't just about finding alternative routes. It's about the very sustainability of global trade patterns we've taken for granted. Alternative shipping routes, once considered expensive contingencies, are now being seriously evaluated. But here's the catch. These alternatives come with their own set of challenges that could fundamentally alter global commerce. As shipping companies scramble to reroute vessels around Cape Horn, a new reality is emerging. One where the predictability of global trade might become a luxury of the past. The reality of alternative shipping routes is hitting harder than anyone anticipated. The Cape Horn Passage, a treacherous journey around South America's southern tip, has suddenly transformed from a historical footnote into a crucial lifeline for global commerce. But this isn't just about longer journeys. It's about the profound reshaping of economic relationships that have defined our modern world. Industry experts are now projecting scenarios that range from concerning to catastrophic. The surge in shipping costs has already sent shockwaves through commodity markets. With vessels taking longer routes, fuel consumption has soared, adding an environmental layer to an already intricate crisis. Ships burning significantly more fuel for extended journeys are raising concerns about sustainability commitments in an era of climate awareness. Major ports are under immense strain. From Singapore's bustling maritime hub to Long Beach's vast container terminals and Rotterdam's massive port facilities, severe congestion is disrupting global trade as ships adjust to new routing patterns. The ripple effect is immense. Delays at one port trigger disruptions throughout the global shipping network, impacting international commerce at every level. Particularly concerning is the impact on smaller economies. While major trading nations can cushion some of the blow, developing countries that depend on efficient maritime trade are facing serious hardships. The increased cost and extended delivery times are threatening essential supply lines for everything from medical supplies to food security. The stock market's response has evolved from initial shock to sustained concern. Shipping indexes are showing patterns reminiscent of previous global crises, but with a crucial difference. This isn't a temporary disruption. This is potentially a fundamental shift in how global trade operates. As the world grapples with these far-reaching implications, attention turns to an even more pressing question: the race against time to find engineering solutions before the crisis deepens beyond control. The engineering battle is racing against nature's clock in the shadow of mounting global pressure. An unprecedented engineering operation is unfolding at the Panama Canal. The crisis at the Panama Canal has evolved beyond simply repairing cracks. It now demands a complete rethinking of large-scale infrastructure. The ongoing restoration efforts mark the most ambitious maritime engineering endeavor since the canal's original construction, with teams working tirelessly in a race against time. At the heart of these efforts lies cutting-edge technology, including AI-powered monitoring systems that track even the tiniest structural shifts in real time. Drawing from a vast network of sensors, these systems provide insights that would have been unimaginable just a decade ago. What sets this initiative apart is the seamless fusion of predictive analytics and hands-on engineering. This isn't just about fixing issues. Engineers are implementing groundbreaking solutions that could redefine the future of maritime infrastructure. Specialized underwater repair drones, designed with advanced materials technology, operate in hazardous conditions where human divers cannot. Guided by precision control systems, these machines carry out repairs with microscopic accuracy, pushing the boundaries of what's possible in infrastructure maintenance. Timeline projections paint a sobering picture. Initial estimates suggested months of work, but as engineers delve deeper into the complexity of the challenges, these timelines keep shifting. The interconnected nature of the problems means that fixing one issue often reveals three more, creating a technological game of whack-a-mole with global trade hanging in the balance. Cost analyses are reaching figures that make even seasoned economists pause. When factoring in not just direct repair costs, but the broader economic impact, the numbers dwarf the canal's original construction costs, even when adjusted for inflation. As engineering teams push the boundaries of what's possible, a new reality is emerging, one where traditional solutions may no longer be enough to combat the forces of nature and time. The scale of innovation being deployed at the Panama Canal is unprecedented in maritime history. Advanced material science meets cutting-edge robotics as engineers push the limits of what's possible. Teams of specialists, working in rotating shifts, are implementing solutions that blend traditional engineering wisdom with breakthrough technologies. The integration of machine learning algorithms to predict structural stress points has transformed this from a repair operation into a technological revolution in infrastructure maintenance. Behind the scenes, a vast network of supercomputers analyzes terabytes of sensor data every hour, powering the most advanced infrastructure monitoring system ever implemented. These systems do more than detect existing issues. They anticipate potential failures before they happen, enabling teams to act proactively. Yet, this predictive capability has uncovered a stark reality. Challenges are evolving more rapidly than conventional solutions can keep up with. The financial stakes are enormous, with initial cost estimates consistently rising as the full extent of necessary repairs becomes evident. And it's not just about direct repair expenses. It also encompasses cutting-edge technology integration, research and development of innovative solutions, and the establishment of long-term monitoring frameworks. When considering the economic impact of reduced canal capacity during repairs, the figures reach levels that command serious attention from government officials and investors alike. What's particularly fascinating is how this crisis has accelerated innovation in maritime engineering. Technologies that were theoretical just months ago are being fast-tracked into development. Specialized repair drones now work in synchronized swarms, capable of performing complex repairs in conditions too dangerous for human divers. These machines, guided by AI systems that learn and adapt in real time, represent a quantum leap in infrastructure maintenance capabilities. Yet, time remains the most precious and unforgiving resource. Engineering teams are working against not just physical deterioration, but also the mounting pressure of global economic impact. Each day of reduced capacity translates into billions in economic losses worldwide. The timeline projections, initially optimistic, now reflect a more complex reality, where the intersection of geological forces and human engineering capabilities presents unprecedented challenges. One of the most fascinating aspects of this crisis is the emergence of innovative engineering methodologies. Traditional infrastructure repair techniques are being completely reimagined, giving rise to adaptive strategies that evolve with changing conditions. Engineers are utilizing self-healing materials and designs that respond dynamically to stress. This is more than just a response to the current crisis. It marks a fundamental shift in how infrastructure maintenance is approached worldwide. As teams work tirelessly to implement groundbreaking solutions, a larger question arises. How will this crisis shape the future of global infrastructure and our ability to sustain it in an increasingly unpredictable world? The future of global trade is at a crossroads. Environmental scientists worldwide are raising alarms that resonate far beyond the towering walls of the Panama Canal. What we're witnessing isn't just an infrastructure crisis. It's a stark preview of how climate change threatens to fundamentally reshape the vital arteries of global commerce. The canal's mounting challenges have stripped away our carefully constructed illusions about humanity's mastery over nature, exposing vulnerabilities that can no longer be dismissed as distant concerns. They're here, they're intensifying, and they're forcing us to confront uncomfortable truths about our interconnected world. The canal's watershed, once hailed as a triumph of ecological engineering, now serves as a warning. Lakes Gatun and Alajuela, the vital sources sustaining this maritime wonder, are showing distress signals that challenge a century of historical records and engineering expectations. Every ship passing through the locks requires an immense amount of fresh water, millions of gallons that are growing ever more scarce as climate patterns become increasingly erratic. The once revered water management system, a symbol of human innovation, now grapples with nature's evolving dynamics, compelling engineers to face challenges their predecessors never foresaw. The geopolitical landscape is transforming as dramatically as the environmental one. Nations are rapidly recalibrating their strategic interests, forging new alliances, and deepening rivalries in ways that echo historical power shifts. China's ambitious Belt and Road Initiative has taken on unprecedented urgency, while Russia's strategic interest in Arctic shipping routes intensifies with each passing day. The United States finds itself performing an increasingly complex diplomatic ballet, attempting to balance its historical ties to the canal with the emerging dynamics of global power distribution.